Assalamualaikum and a very good day. My name is Muhammad Eizairy bin Muhammad Yusri 2018224812, and today I'm going to present on my final year project with the title of IoT-based water quality monitoring system and test for swimming pool water physicochemical quality. I am currently under supervision of Professor Zulkifli Mohamed. Despite advancement, we humans still facing problems regarding water quality as well as water quantity. Water is known to have a very significant role in our daily life, including hydrations, recreational activities, agriculture use, and many more. It is always important to ensure the water quality as it have direct impacts towards both health and safety of the user. Most of the time, swimming pool water quality monitoring could be a hassle and time consuming. As of today, the evolution of water quality monitoring can be seen from the conventional lab-based approach to manual on-site based approach and to wireless sensor network approach. Introduction of IoT, Internet of Things, can provide automates with real-time data and also easily monitored from anywhere. IoT is a system that famously known to require simple embedded device, minimal footprint, and reduced operation costs in an extensive use. Polluted water, either physically or chemically polluted, is hazardous to health and exposed better to after effect. Swimmer or athlete usually spend more than 2 hours in the swimming pool. Conventional method, which is the lab-based approach, and manual on-site approach are difficult as it demands more time to monitor and demand manpower to take the sample and bring to the lab, or maybe a person in charge to monitor the water quality on-site. For lab-based approach, usually the quality assessment is outdated. There is also a use of one-off testing kit. However, this approach is somewhat provide less finding and less accuracy. Current system is time-consuming, and for the wireless sensor network or automation in monitoring system, it is usually costly and thus encouraging people to neglect water quality monitoring. Besides, lack of knowledge from the swimming pool water management authority or person in charge regarding the crucial parameter also contributes to water quality problems. The recognition of crucial parameter is important to ease monitoring water quality. In tackling all the problems stated earlier, there are three objectives of the study. First, to develop an IoT-based water quality monitoring system with two physicochemical parameters, which is pH and TDS. Next, to calibrate the system in ensuring the validations of the data measured both on-site and also using mobile device. And lastly, the objective is to test run the developed prototype in real swimming pool application before the measured result is analyzed and compared with standards and regulations. These are the scope of work throughout the study. First and foremost, the parameter identifications. The study focused on physicochemical parameter. Parameter includes temperature, total dissolved oxygens, turbidity, and of course the one used in this project, which is pH and TDS. Identifications of the best parameter is based on literature review. This part is crucial as to satisfy objective number 1, only the most important parameter is needed. This part of work may not seem to be crucial, but the thing is, the identification of right parameter have actually drive the study. Second is system development and integrations. This part of work is where both elements, which is the hardware and also the software, are integrated so that the system works well. The activity includes the installations of the hardware, the calibrations, code writing, and many more. Next is experiments. Sample for swimming pool was taken to undergo experiment and also testing for the system in real application. The system, which has been validated in previous part of work, function very well in the scope of work. Fourth is data analysis. This part of work is where all the data measured in the experiment will be compared with several standards and regulations related to swimming pool water quality. The comparison taken into consideration both pH and also TDS parameter before the discussions. Last but not least is future work. The finding and conclusion have been made after data analyzation. The finding can be useful as to a proper action taken to ensure water quality of swimming pool. These are the flowchart for the whole project. As you can see, it covers all the activity from the start until the end, and it can be divided into 3 sections, which is according to the research objective. These are the only 3 hardware being used in the system. First is the microcontroller, which is ESP32 TTGO LoRa. It works as a Wi-Fi module and also have the built-in OLED display. And the other two hardware is the pH sensor and also total dissolved solid sensor. As for the holder of the sensor, I have used computer-aided design software CATIA to design the holder and then 3D print it as the prototype. This is the final outcome of the product. These are the two software being used for the development of the system. Blink application is used as the data visualization applications through mobile device, and also the Arduino IDE integrated development environment is used to write and upload the system programs to the microcontroller, and the system supports C++ language for coding structure. How the system is going to work. So the two sensor, which is pH sensor and TDS sensor, will gain input from the water and convert it from physical change into electrical equivalent. The inputs will transfer into ESP32, which has been programmed using Arduino IDE. The data can directly display in ESP32 OLED display, or with the aid of Blink server, the data can be visualized in Blink applications. Due to the pandemic COVID-19 restriction, the experiment cannot be done on site and thus require me to take the sample from the swimming pool and do the experiment from home. Even from the picture shown, we can clearly see that the swimming pool is closed from public usage. The experiment is being done within 3 hours to make sure the properties of the sample stay the same. This is the video of me taking the sample water from the swimming pool for the experiment purpose of this research. Before the data analysis of the calibration process, I will demonstrate the calibration process. Okay, so now I'm going to calibrate the pH sensor that is going to be used on my system. So we need 3 solutions here. The first one is pure distilled water, the one that I already poured here. It's going to be used to clean the props during the calibration process. And the other 2 solution is the buffer solution with pH of 7 and also pH 4. So first of all, we need to open the lid of the buffer of the pH sensor, and then we need to dip into the pure distilled water just to clean it up before the calibration process. And then we need to gently dry the prop. To make sure there is no excess water. Gently clean it, dry it, okay? Be careful because the prop is quite sensitive. So now, after finish, I will dip in the buffer solution with pH value of 7. I'm already opened the seal and the cap before the recording sessions, and now I'm going to dip in the buffer solution. We need to wait for a few seconds so that the reading is stabilized. And to enter the calibration mode, we need to type enter pH in the Arduino IDE. And then I need to write cal pH so that it can detect what types of buffer solution. Okay, so once it detects, then I need to save by writing exit pH. So now the calibration process is done for the buffer solution number 1. So now I need to clean, to dip in the distilled water just to clean it, any excess. Then again gently dry it. Okay, now I'm going to dip in buffer solution pH 4.0. So I need to wait for a few seconds so that the measurement is stabilized. Once the reading already stable, we can enter the calibration modes. And then wait for few seconds so that it become more accurate, and then calibrate pH. So it already detect buffer solution with pH value of 4, and now we need to save. What we need to do is we need to exit pH. Okay, it's already done. As you can see here, pH sensor have undergo 2-point calibration procedure. This is to ensure a better accuracy and also a broad range of accuracy compared to only 1-point calibrations. So on the blue side is the first point calibration using pH 7 result. The buffer solution reading have significantly dropped from 20% to only 0.14% of percentage error. And for the white side is the second point calibration using pH 4, and the percentage error have dropped from up to 18% to only 0.25%. This is the pH sensor percentage error after successful calibration. It is important as the system validation process. It ensures the overall credibility of the data measured by the system. You can see that the percentage error dropped from in the range of 17.5% to 20.57% to only 0 and 0.25% after the calibration process. Before the data analysis of calibration process for TDS sensor, I will demonstrate the calibration process for TDS sensor. So now we are going to calibrate this TDS sensor from KS Studio that we are going to use in the system. To calibrate this TDS sensor, I'm going to submerge the sensor probe into the solution. The solution I've already added a pinch of salt so that it have some ppm value in it. I am using this TDS meter or TDS pen to verify the solution ppm value. This TDM meter already been calibrated using this TDS solution. The reason why I didn't use this TDS solution is because the ppm reading exceed the measurement range for this TDS sensor KS Studio to be used in the system. So first of all, I'm going to submerge this TDS pen into the solution to get the reading of the solution. We need to wait for a few seconds so that the reading is stabilized. And here is the reading for the solutions. 590. So now, I'm going to put this sensor into the solution. While in the meantime, I'm going to open the serial monitor so that we can enter the calibration modes. To enter the calibration mode, just type ENTER and then just write the amount of ppm read by the TDS meter used previous. Just write CAN _590. And now this TDS sensor have already detect 590 ppm in the serial monitor. And to exit, we need to type exit so that it can save the value. And now the calibration process is successful. The calibration process for pH sensor is different with TDS sensor. TDS sensor calibration needs the use of predetermined ppm value in a solution. So TDS sensor calibration require other TDS meter to determine the ppm value of the solution. And then the calibration has been done when we put in the ppm value of the measured solutions. And the percentage error after the calibration process is only 0 to 0.34%, which is quite low. Graph show the pH reading of swimming pool water sample. I have taken 3 different average with 10 readings for each average. So the biggest difference between the highest and the lowest value is measured at average 2, which is with a difference of 0.15, and for average 3 the difference is 0.09, and for average 1 the difference is 0.08. At the same time, TDS value was also measured with the same interval of 1 second between each reading, with total of 10 readings for 3 different average. And on contrary to pH value measured, based on the figure, the value measured almost remained constant. Only slight difference in TDS measurement was in reading 5 among average 1 and also on reading 4 among average 2. This is the overview of pH and TDS reading from the swimming pool water sample. You can clearly see that the reading is not much of a difference, and they show the consistency of the data measured. The data show the comparison between the average measured reading of pH and TDS of the swimming pool water sample with 5 different standards and guidelines. So the standards here are from WHO, Ministry of Health Malaysia, New South Wales Ministry of Health Australia, Pool Water Treatment Advisory Groups of United Kingdoms, and also American National Standard Institutes. So as clearly see here, pH reading for all 3 average measurement notably exceeds all 5 standards and guidelines. So most of the standards and guidelines have a safe range of 7 to 7.8 pH, while for Pool Water Treatment Advisory Group have a quite strict range of only 7.2 to 7.4. So the pH reading for all 3 measurements exceeds all the standards and guidelines. According to WHO, a high value of pH are known to cause skin rashes. Based on this observation, it is clear that the water is not safe, even with the additions of disinfectant. pH of a swimming pool should be managed well to ensure the efficiency of the disinfectant, because the efficiency is highly depends on the pH value of the water. The inability for disinfectant to work efficiently or as intended will promote the growth of microbial hazards, including bacteria. Overall, it shows that the water in the swimming pool has been highly spoiled despite its clear property. So for TDS value measured, which is 266, 267 and 267 ppm, it is remarkably very low, and it does not exceed any of the standards. However, WHO does not define any figure and only stated that increase in TDS and meaning the lack of dilutions. So the TDS value measured pass all the standards and guidelines. One of the possible reasons why the swimming pool have a high pH value is probably due to the extensive amount of disinfectant use. With the pandemic, COVID-19 has forced the closure of the swimming pool. The management may take the maintenance aspect of the swimming pool lightly. While this may be true, the TDS value does not seem to agree with the statement. An extensive amount of disinfectant can affect the TDS value to be more than 1000 ppm. Hence, contrast with the possibility of extensive amount of disinfection. Chemical additive, disinfections and better release will contribute directly to the increased amount of TDS value. Based on American National Standards Institutes, the use of water for prolonged period and exposure to sunlight may further increase the pH value. This is true as the swimming pool being analyzed is an outdoor pool, and the pool is also being closed for longer period. Thus, the management may have no urgency to change the water. Therefore, with all the discussion, it is crystal clear that what is the factor contributing to the result measured. pH value is exceeding all the standards and guidelines compared because of the prolonged use and exposure to sunlight. This is proved not by the excessive disinfectant, as the TDS value is significantly low. The low measured TDS value encouraged by the absence of swimming pool user and lack of disinfectant added by the pool management. As for the conclusion and recommendations, in this study, an easily accessible IoT-based water quality monitoring system has successfully been developed and tested in a real swimming pool application. The percentage error of the measured value has been minimal due to the calibration process of the both sensor. Percentage error significantly drops from as high as 20% to only 1%. This is crucial as it determines the validations of the system to monitor the parameter intended. The data from the system able to visualize in microcontroller OLED display, mobile phone through a Blink application, and also Arduino IDE serial monitor. And as for the recommendations, the data analyzed was compared with several standards and guidelines. It is found that the water is not safe and already polluted. The cause of the pollution has also been recognized based in these discussions. The water is needs to replace as a whole when swimming pool is reopened. Thank you panelists and viewers for your time. For any question regarding the project and the presentations, you can directly contact me. Thank you.